to your client. While it's certainly possible to come up with your own methodology, there are a couple of methodologies that are available, and you can certainly use those as a starting point. And you probably will want to, over time, do some refining as you continue to work more and know what works best for you and the types of engagements you have. These open source methodologies have an advantage of being available and put together by people who've put a lot of thought and have a lot of experience, but they're also very generic and not targeted to maybe the types of engagements that you expect to be working on. So while they're great starting points and you may very well use them on an ongoing basis and never make any changes, don't assume that you can't make changes to these or that they're something that's set in stone and you should never ever change them. The Institute for Security and Open Methodologies has this thing called the OSSTMM, which is the Open Source Security Testing Methodology Manual. You can find it online. You can see here I've got a PDF open of it. It's a pretty big document. It's got all sorts of extraneous information, which is important to the people who are involved in it. You've got the contributors here. And it takes several pages before we get down into the actual meat of the document. But let's take a quick skim through the table of contents. Section A is information security, and they talk about doing a competitive intelligence review and a privacy review and just document grinding. And document grinding is getting architecture documents and policies and procedures and any sort of documentation that you can get from your client or your target and just digging through it to see what you can find and what you can learn. Section B is about process security. It talks about risk assessment values, and they talk about request testing and guided suggestion testing and trusted persons testing, and those are 3 different types of testing that they have guidance around. Section C is all about internet technology security. Again, they talk about risk assessment values, and the modules for this particular section include logistics and controls, network surveying, competitive intelligence review, privacy review, the document grinding, vulnerability research and verification, internet application testing, which would be probably web applications, although it may include just network-facing applications, routing, trusted systems testing, access control testing, intrusion detection system testing, containment measures testing, password cracking, denial of service, security policy review. Then we get into communication security, where we're dealing with PBX testing and voicemail testing, and possibly a fax review, as well as looking at modems. There's a section for wireless security, and we talk about the different types of wireless networks, including Bluetooth and wireless input devices and handheld security, cordless communications, and there's also sections for RFID and infrared systems testing. So as you can see, there's a pretty detailed and comprehensive amount of information in this particular methodology document. They take a lot of things into consideration. There's also physical security, which is something that is definitely worthwhile to look at, although it may or may not be something that you would get into as an ethical hacker. Physical security is really important. It involves not only the perimeter with respect to things like fencing and guardhouses and those sorts of physical security measures, but there's monitoring, and there's also inside. This would fall under the environment review. There's things like a clean desk policy, and whether people have left information up on whiteboards that could be gathered by visitors coming through the building, or whether there's sensitive documents that have been left out on people's desks. There's also some templates here for reporting. There's some social engineering templates here, which are useful if you start getting into social engineering aspects. I wouldn't necessarily expect that you would be following this entire methodology on every engagement that you were involved with, but this is definitely a good set of information, certainly as a starting point for you to follow as you are starting to work into doing ethical hacking. Another methodology here is from the OISSG, and this is a penetration testing methodology. You can see here they've got a wiki set up and some similar sorts of things, although this is more targeted at an actual penetration test, where the other one is more geared towards something that's closer to a security assessment, where you're assessing the entire risk posture of the organization and you're doing a full round of security testing. This methodology is more targeted at, I just want to see if I can break in, and what you would do to do the penetration and how you would handle that, as well as getting out and covering your tracks, and also cleaning up and destroying any artifacts from your test. So there's not a cookbook here of these are the steps you take. It's a methodology document where at a somewhat high level, you want to talk about the different steps you would take to achieve the different goals that you have for your penetration test or your security assessment or your ethical hacking engagement. And that's the purpose of a methodology. In this lesson, we're going to be talking about types of attacks. One type of attack that you'll find common, particularly in cases of hacktivism, for example, or cases where people are trying to make a particular point or just be a general pain, is this idea of defacing. Defacing goes back for quite a while. It's the idea of sort of digital graffiti, where you've left your mark or your imprint behind so that everybody knows you were there. Primarily a website thing, and it's really just making alterations to something. It used to be pretty common a long time ago to have particular businesses or people or just organizations in general to have their home pages be replaced by this other thing that was along the lines of, hey, I was here and I took over your page. We also have a pretty common one, or certainly has been common over the years, and it's a pretty good path towards quality exploits and high-profile vulnerabilities, and that's buffer overflows. A buffer overflow is a result of the way programs are stored in memory. When programs are running, they make use of a chunk of memory called a stack, and it's just like a stack of plates. When you put a bunch of plates down, when you pull a plate off, you're going to pull the top plate. You're not going to pull the oldest plate. You're going to pull the one that was on top. So the same thing with a stack here. When we're accessing memory, and this has to do with the way functions are called in memory. When you call a function, a chunk of memory gets thrown on the top of the stack. That's the chunk of memory that gets accessed. And you've got a piece of data in memory within that stack, and that's called a buffer. And when too much data is sent and tried to put into that buffer, it can overflow the bounds of the configured area for that particular buffer. Now, the way stacks are put together, we end up with a part of the stack where the return address from the function is stored. So when you overflow the buffer, you have the ability to potentially overwrite that return address, at which point you can control the flow of execution of the program. And if you can control the flow of execution of the program, you can insert code into memory that could be executed. And that's where we get buffer overflows that turn into exploits that create the ability to get like a command shell or some other useful thing from the system where the buffer overflow is running. So that's a buffer overflow in short. We also have format string attacks. And sometimes these can be precursors to buffer overflows. Format strings come about because the C programming languages makes use of these format strings that determine how data is going to be input or output. So you have a string of characters that define whether the subsequent input or output is going to be an integer, or whether it's going to be a character, or whether it's going to be a string or a floating point, that sort of thing. So you have a format string that defines the input or the output. If a programmer leaves off the format string and just gets lazy and provides only the variable that's going to be output, for example, you have the ability to provide that format string. If you provide the format string, what then happens is the program starts picking the next pieces of data off the stack and displaying them. Because of that, we can start looking at data that's on the stack of the running program just by providing a format string. And if I can look at the data, I may be able to find information like a return address or some other useful piece of information. There's also a possibility of being able to inject data into the stack using this particular type of attack. Denial of service, this is a pretty common one. You'll hear about this a lot. This is not to be confused, though, with the one that I'll be talking about after this. A denial of service is any attack or action that prevents a service from being available to its legitimate or authorized users. So you'll hear about a ping flood, a SYN flood, a Smurf attack, and a Smurf attack has to do with ICMP echo requests and responses using broadcast addresses. That one's been pretty well shut down over the last several years. You can also get a denial of service simply from a malformed packet or piece of data, where a piece of data is malformed and sent into a program. If the program doesn't handle it correctly, it could crash. If it crashes, suddenly you're not able to use that program anymore. Therefore, you are denied the service of the program, thus a denial of service. As I said, a denial of service is not to be confused with a distributed denial of service, and I know it's pretty trendy, particularly in the media, to call any denial of service a DDoS. Any denial of service is not a DDoS. A DDoS, or distributed denial of service, is a very specific thing. A distributed denial of service is a coordinated denial of service making use of several hosts in several locations. So if you think about a botnet as an example, a botnet could be used to trigger a distributed denial of service, where I've got a lot of bots that I am controlling from a remote location, and I'm using all of those bots to do something like sending a lot of data to a particular server. When I've got a lot of systems sending even small amounts of data, all of that data can overwhelm the server that I'm sending it to. So the idea behind a distributed denial of service attack is to overwhelm resources on a particular server in order to cause that server not to be able to respond in a normal way. The first known DDoS attack used a tool called Stacheldraht, which is German for barbed wire. Stacheldraht came out of some work that a guy by the name of Mixter was doing in 1999. He wrote a proof of concept piece of code called TFN, which was the Tribe Flood Network. The Tribe Flood Network was then turned into something called Trinu, and Trinu was used as more or less the basis for this program called Stacheldraht, which was then used to attack servers like eBay and Yahoo back in February of 2000. So that attack in February of 2000 was really the first known distributed denial of service attack, which is not to say that there weren't denial of service attacks previous to that. There certainly were plenty of them, but they were not distributed in nature, meaning there weren't a lot of systems used to coordinate and create a denial of service condition, and therefore we get the distributed denial of service attack. So that's a handful of types of attacks and some pretty common attacks that you're going to see. In this lesson, we're going to be talking about different skills that are required or will be learned as part of this series of videos. So initially, just for basic computing, You need a basic understanding of operating systems and how they work and how to work them. There are going to be several fundamental types of tasks that I won't be going into any detail at all on. You'll need to know how to run programs and do things like open up a command prompt without me walking you through how to do that. I'm going to assume that you have some basic understanding of how to do those sorts of tasks. You need an understanding of basic system software, and you'll need a basic understanding of how to use command line utilities. There are a number of tools and programs that we're going to be going over through this series of videos. Many of them use the command line, whether it's on Windows or Linux. You need to be familiar with typing and being able to run programs from the command line and the various command line switches and parameters that those types of programs use. From a networking perspective, you need a basic understanding of some simple networking concepts. Know what cables are and switches and hubs and how systems are networked together. You don't need a deep level of networking understanding. I'll be going through some protocols at a reasonably deep level because I think it's important as an ethical hacker to understand what's going on at the protocol level so that you can know better what you are doing and how to achieve the goals and tasks that you have before you. So we're going to be going over some protocols, so just understanding what protocols are and how they go together, those sorts of things are necessary from a networking perspective. Life skills. Yes, there are some life skills that it's important to have. I think the most important one is the ability to accept failure and persevere. By that, I mean that you're going to be running across several things that just don't work the first time around, and it's going to take a little bit of stick-to-itiveness to plug away and keep going until you get something to work. And the way that you get things to work is having an ability to problem solve. And sometimes solving problems requires being a little creative. Sometimes you need to think out of the box and come at a problem from a different perspective in order to find the solution and the way forward. You're going to run across a lot of sticky problems through the course of learning about being an ethical hacker and just doing the work, because it's not as simple as, here's a little recipe for how to do this, now go follow this recipe every time and you're going to be successful. Every situation is different, every system is different. You're going to run across some pretty sticky problems that you're going to have to just wade into and get your hands dirty with and keep failing and failing and failing until you find a way to succeed. So I think those skills are very necessary to learning how to be an ethical hacker and digging through some of the material that we'll be going over in these videos. As far as what you're going to be learning, you're going to learn how to use a lot of tools. You're going to learn networking. And by that I mean we're going to be talking about different protocols that are involved in networking systems together. You're going to learn about security. Security is the heart and soul of ethical hacking. It's why we do ethical hacking, in order to make systems and networks more secure than they were previously. That's the goal. From a networking perspective, we're going to be talking about how to read packets from network captures. We're going to go into TCP/IP and related protocols in a fairly significant amount of detail. You're going to understand how protocols interact with one another. So we're going to do all of that, and the reading packets is going to be really important. We're going to do a fair amount of that, in addition to just a fundamental approach to learning how to read packets. In several lessons, we're going to read packets as a way of understanding the different tools that we're using and how they work. You're going to learn tactics and methodologies. You're going to learn ways to use the information you've gathered in order to get more information. And information is really what this is all about. You can't do much of anything without information, and sometimes it takes a fair bit of digging in order to find that information, and what you're going to learn is the entry points and the stepping stones to get the information that you need. And then once you have that information, you're going to be learning about ways to exploit it in order to get deeper into the target. You're going to learn security awareness. We're going to be talking about risk and understanding risk and vulnerabilities, primarily recognizing the difference between a vulnerability and an exploit, and there's a significant difference there. So security awareness and understanding what a risk is and how that impacts your target is going to be pretty key to a lot of things that we talk about. So it sounds like a lot. We're going to cover a fair bit of ground, not all of it at a deep level. Sometimes we're going to skim the surface, but there's an awful lot of material to cover. So let's get started. In this lesson, we're going to be talking about penetration testing and some of the details around how it works and logistics and specifically things like scope. So what is penetration testing? Well, not surprisingly, it's testing to see if you can penetrate something, which means you're going to check to see whether you can break into a particular thing, whether it's a server or an application. Depending on the type of engagement you've got, you may have the ability to try to break in physically to a location. But primarily, what you're going to be doing with penetration testing is you're going to be trying to break into systems and networks and applications. That's kind of what it's all about. This may actually involve social engineering attacks, so it may require you to make a phone call to somebody and get them to give you their username and password, or some other type of social engineering attack where maybe you send a URL via a crafted email. Sometimes it's just strictly a technical approach where you're running scans and you're running Metasploit and you're gaining access that way, or maybe some other type of technical application sort of connection. Sometimes it's physical access that you need. So in order to get access to a particular system, if you can get physical access, then maybe you can get in. So what are the goals of penetration testing? Well, the goals would be to assess weaknesses in an organization's security posture. You want to figure out where they're vulnerable so they can go fix these problems. You want to help them understand their risk position better and what they can or may be able to do to mitigate those risks. And ultimately, you want to be able to access systems in a particular way to find weaknesses. So those are really sort of the goals of penetration testing. From a results standpoint, when you're done your testing, what are you going to do? Well, you're probably going to generate a report. And by that, I don't mean you're going to run some automated tool and you're going to get it to generate a report for you and you're going to give that to the client and then they're going to write you a really large check. That's not really how it works. You're going to write a report detailing the findings in a detailed way. So what did you find? How did you find it? How can you go mitigate that particular risk? So you should really include remediation activities in order to fix the vulnerabilities that you find. It's pretty easy to walk around going, hey, that's a problem, and that's a problem, and that's a problem. There's really not a lot of value in that. Where there's value is, hey, that's a problem, and here is how you can go about fixing it. So let's talk about scope. How big is the breadbox? And specifically, what is it that the two of you have agreed to? So you as the penetration tester and them as the target organization or the client, what have you agreed to? Are there any exclusions? Are there any areas where you're not allowed to touch anything? So if they've got a database server, maybe there's a lot of really sensitive data on it and they're a little hesitant and they may put a don't touch this clause into the scope. So there's a lot of different reasons why they may exclude areas from the scope. And if they exclude them, trust their reasons and listen to what they have to say in terms of this is what we want you to accomplish. So along those lines, you really need to get sign-off from the target organization. We've talked about this before. This is certainly all about ethics and trust, and it's also about legality, because if you do something that you don't have permission to do, you could be prosecuted for that. So definitely get the scope very clear and in writing and with signatures attached to it as to what you can and can't do. Always get approval from the right people. Make sure you get somebody who has the right level of permissions and is the right level of management so that they can sign off on it, understanding and accepting the risk that is associated with a penetration test. So let me talk a little bit about security assessments and how they differ from penetration tests. A security assessment is a hand-in-hand approach with the client. So you would walk in doing a collaborative thing where you're a trusted partner and ally with them, and your goal isn't to penetrate them and point out all of the things that are really bad, but it's to get a full assessment of the risk that the organization is exposed to. You would probably provide more detail about fixes than maybe you would in a penetration test. What we're going to do is we're going to walk in and make sure that the policies and procedures they have in place are really what they need for the organization and the risk appetite that they've got. And we're going to make sure that the policies and procedures have controls that can tell us whether they are being actually adhered to or not. So the procedures and policies are being followed. A security assessment is probably a little bit more comprehensive than a penetration test. You would look at more factors to assess the security posture of the organization and their overall risk, and you would tailor the output based on their risk appetite and what they're most interested in. And that's not to say that I'm going to tell them what they want to hear, but if there's something that they know and I know that they're just not going to do, I'm not going to make a big deal out of it because they're already aware of it, and I'll make note of it in the report just for completeness sake, but I'm not going to go into a lot of detail. So it's really kind of a hand-in-hand collaborative approach where, again, we're not just saying what they want us to say, we're providing some real security and risk guidance toward their activities. The other thing about a penetration test is it may provide an unrealistic view. So you've got a week, let's say, to do this penetration test against your target. Now you're going to have to go in, you're going to have to get set up, and you're also going to have to start doing a bunch of scans and make sure that you're gathering information and screenshots and data for your reports. You're going to have to do all sorts of activities. Also, during the course of that week, you're going to be engaged in probably beginning to write your report and getting a sense of what it's going to say and what's going to be in it. If you don't actually get any major penetration during the course of that week, the organization may feel like they are quote-unquote secure. That's one of the reasons why penetration testing, while really sexy and showy, is nice and all, but if an organization walks out of it believing that in a week you didn't manage to, get the keys to the kingdom, then they must be secure. That's a really misguided view. Because a dedicated, skilled, and motivated attacker isn't going to just take that week or some portion of that week. If they're after something, they're going to dedicate themselves to it and really go after it. So just because you didn't find a penetration in some subset of a week doesn't mean that they are secure and invulnerable to attack. It just means that during the course of that particular week and other circumstances that were in place, you didn't get a penetration that was really significant or major. That's all it means. It doesn't mean anything beyond that. And if an organization walks away feeling like they're secure, then they're going to end up not fixing the real vulnerabilities that may be in place that could expose them to significant risk. So that's penetration testing and scope and security assessments. In this lesson, we're going to be going over footprinting. What is footprinting? Well, footprinting is getting an idea of the entire scope of your target. That means not just the scope that you were given, which may be an address block, or it may be a domain name, or it may be a set of address blocks. What you want to do is you want to figure out all of the information that's associated with that in as great detail as you can possibly get. So you want a list of domain names. And as you're going through this, you probably want some sort of database or Excel spreadsheet or something to keep track of all of the information, because you're going to have a lot of it at the end of the day. So you want to be able to find the information quickly. And so having some sort of either notepad going with your notes, or, as I said, a spreadsheet or a database if you can get organized in that way. But you want to keep all of those sorts of things down. So in this case, I want to do infiniteskills.com. I need network blocks. So far we've found one, and that's just a made-up IP address because I'm just putting information down. But I need network blocks. You may only have one IP address that you can find externally. You're going to want a whole range of internal blocks, and you can do a little bit of digging if you aren't provided those. You want specific IP addresses.